To start on compound interest. Compound interest is what all of your savings accounts at the bank do. They pay interest on top of interest. It is fantastic. So here is the compound interest formula that is paid n times a year. So A, you know, because we dealt with that before. A is just going to be your total or your future amount. Because on some problems it might say my goal is to have so much in my account. P is going to be the principal or your initial amount. R is the rate as a decimal. And T is the time in years. And so N is the new one. N is the number of compounding periods. So the more often an account compounds, the more interest on top of interest that you end up earning. And so the compound period, N, is the period of time between interest payments. There doesn't really seem to be any rules, regulations, or norms, so I think that banks can compound as often as they want to, and I'm sure they do whatever most banks do to be competitive, so that if people were looking at that as their decision for where am I going to bank, that might be one of the things that they look at. So if an account compounds annually, then your N is going to be 1, and that just means interest is paid once a year. If we have the semi-annual sale, how often do we have the sale? Twice a year. So N is 2. So interest is paid twice or 2 times a year. Maybe a bank would compound it quarterly. How many quarters are in a year? Okay, so N would be 4. Interest is paid 4 times a year. I think that monthly is very common. So N is 12. So interest would be paid monthly or 12 times a year. Based on the banker's rule from yesterday, where a bank does easy math and they say that there are 30 days in a month, and so therefore N equals 360. So interest is paid 360 times a year. All right, so Susie invests $1,200 in an account, paying 3.6% interest, compounds annually. She makes no additional deposits. How much will she have in her account? All right, so this one, when you see the phrase compound, that means you're going to use this formula. So I know that this is the formula I'm going to use. 1 plus R divided by N to the NT. So you know we're on the Vincennes University program, and the Vincennes University program states that I am allowed to give no formulas whatsoever. So this formula right here, I need you to commit to memory, and I plan on having a quiz on Thursday. And then there's also going to be the formula from yesterday. So that also was, there was interest involved, but there was no compounding. So please start committing yesterday's and today's to memory. All right, so I'm going to invest $1,200 in an account. So that is my initial amount. So I'm going to plug $1,200 in for P in a minute. I earn 3.6% interest. And so that's my rate. I went ahead and moved it 2 to the left, and so my R is going to be 0.036. It compounds annually, so that is my N, so N is 1. And I want to know how much I have in 12 years, and so T is 12. All right, so now you just need to sub it all in. 1 plus 0.036 divided by 1 to the 1 times 12. Of all the things here, the exponent is the thing that concerns me the most. I think we did this with payment maybe a little bit last week. So if you have two numbers right here in the exponent, I highly recommend you always multiply that together so that you aren't trying to do any multiplication in your calculator in an exponent, because sometimes you don't always put the order of operations in correctly. That you should be able to handle in your calculator all at once to give me one single answer right now. All right, so calculator should have said 1834.42. Jimmy is also going to put $1,200 in an account. He will also earn 3.6% interest. However, there is no compounding. How much will he have in the account after 12 years? All right, so there's no compounding. So this is what we did yesterday. So yesterday's formula with no compounding is A equals P times 1 plus RT. So P is still 1,200. My rate is still 0.036. And T is still 12. So I have 1,200 times 1 plus 0.036 times 12. All right, so they're running the numbers, and did you get it? So you should have gotten $1,718.40. All right, so here in this one, we have compounding. In number 2, we have no compounding. All right, so on the quiz, I'm not going to say there is no compounding, but when you don't see the word compounding, that's when you're going to have to know and infer that this is the formula that I use in that instance. So these are the two formulas and scenarios that you're going to have on your quiz. All right, so we have 1834 versus 1718. So if you choose a bank that compounds, how much free money did you just get out of the bank by choosing the bank that compounds? I don't know, at least $100 in free money just by choosing the right bank. So that is the difference of compounding. And if it had more money and a decent interest rate, that difference would magnify. All right, let's go to the next one. we're going to put 2,000 in an account that pays 4.5% interest compounded monthly. Find how much money I have after 20 years. So as soon as you see the word compounding, that is what your cue is to go, oh, this is the formula that I use. So that is what you're looking for. I'm going to put in 2,000, so that's my principal. There's my rate. Compounding is your N, and it compounds monthly, so therefore N is going to be 12. And 20 years, so T is going to be 20. So I'm not going to rewrite the formula because I have it right here. So I'm going to just sub in all the numbers. So this is an instance where I have numbers being multiplied in the exponent. So I would definitely do that math in my head or calculator and make sure that you only enter one single exponent into your calculator. Then you will probably get the right answer. And they should have ended up at $4,910.93. Don't overcomplicate this. Some people did on the quiz. How much interest was earned? So what you're going to do, so this is my total in the account. Of that balance, how much interest did I make? All right, so all you got to do is subtract. So if you take your current balance minus the principal, so I'm taking the 4910.93 minus the 2,000 that I deposited, that means that I have 2910.93 is how much I earned in interest. So I left it in there so long, my interest is more than my principal at the moment. C says, how much would be needed for the principal investment? How much would be needed for the principal? So in this case, the principal is my unknown amount. I want my account to be worth $10,000, so that is indicating a future amount, and that variable is A. So now I need A to be 10,000 in this scenario. And I'm changing my time frame to 18 years. I meant for it to be implied that we're still using the 4.5% and we're still compounding monthly. So those two things I meant to take from the initial problem. So my rate is still 0.045 and my N is 12. So equals P times 1 plus R divided by N to the NT. So now I'm going to go substituting in everything that I know. So help yourself get partial credit just in case you make a mistake along the way. I like seeing the formula. I like seeing direct substitution. And then you can run the numbers in the calculator. So I'd probably take 12 times 18 and get 216. So all that right there, that you can certainly stick in your calculator. This is what I would call an intermediate step. So some of you have really good calculators and some of you, it's fine. So in an intermediate step, we're going to use 4 decimal places. 2.2445. So if your calculator can't hold the amount, then I would use 2.2445 is what I mean when I say round it to 4 decimal places. And then all we have is an algebra problem. I'm going to divide. So I'm solving for P, which is money. And so when you go top divided by bottom, let's always know that money rounds to 2 decimal places. 4455.34. So if mom and dad, grandma and grandpa had about $4,500 sitting around, and they put it in an account when you were born, and that account earns 4.5% on your 18th birthday, they would be giving you $10,000. All right, I'm going to hit the pause button, and y'all are going to try 4. All right, so on the next one, I want to have 15,000, so that is my A, that's my goal amount. After 5 years, so T is 5, 6%, so my R is 0.06. It compounds semi-annually, so N is 2. And it says, how much do you need to invest? And so that tells me that the P is my unknown variable that I am solving for. 1 plus R divided by N to the NT. So my 15,000 goes there. The rate is 0.06 divided by 2. 2 times 5. 2 times 5 is 10. I entered all this in my calculator, and I got 1.3439 when I rounded to 4 decimal places. I divided both sides by 1.3439, and that's how I got 11,161.54. If your calculator is able to hold that number, that's fine, because you're only going to be off a few, I don't know, pennies from me probably. Number 5 is mostly the same. All right, so also in number 5, I'm going to borrow with an interest rate of this. I'm going to borrow that, so that is your P. My interest is 0.143. That's a really high rate. Compounded quarterly, so that's my N. What is the amount needed to pay back in 42 months? So my T is 42 months. So you can either enter it as a fraction, where the T is, or if you go top divided by bottom and you get a terminating decimal, then you could use that. So in this case, I got 3.5, so maybe 3.5 is going to be a little bit more user-friendly in some of your calculators. But if you do top divided by bottom, and that would have been a repeating decimal like 3.33333, then I need you to use the fraction. You're not allowed to round. All right, so now we're just going to do more of the same. and we're going to figure out how much interest did you pay on this. And I'm going to hit the pause button because this is just more of the same. All right, so here are the answers. So on number 5, you should have gotten $133,815.49 if you wanted to know how much interest you paid. So take that future amount minus your principal, and that's how much interest that was paid. And then on number 6, you borrowed $2,300 for tuition. So those of you that are planning on going to college, when you put your account on hold, so you borrow money from the government to go to school, and there are 2 kinds of loans. Some of them accrue interest while you're in school, and some of them do not accrue interest while you're in school. So when you're looking at your federal student loans and you're trying to decide which loans to take, I can't remember the exact term, I would have to look it up. But if it says that the interest is deferred until after you graduate, you definitely want to take out those loans because that's like free money to you. But there's other loans that say that interest is going to compound and accumulate while you are in school. And so if you don't need all of your money, like if your family has some saved, you should deny those and reject them, because this is what happens. So this person borrows $2,300, and after 5 years, so now their $2,300 is up to $2,900, and now that's what they're going to start having to pay back. So you have fun with the homework, and we'll do it again tomorrow.